Hey, is the microphone working? Cool. All right, welcome everyone to my talk about re-architecting applications without having to do a full rewrite. So to get started, I want to make sure we were kind of all on the same page, defining what I think of as architecture. So hold on one second. So architecture for me is a definition I got from a dictionary, the structure and design of a system or product. So I'm talking about pretty much any system or product here. I think a lot of architecture talks go over like the very high level stuff. And so normally, I don't know why it's not advancing, there we go. Normally when you think of architecture in terms of houses, you think of like the overall structure. You've got this nice blueprint which shows you the general shape of the house. And that could be your high level architecture for your application. But I also really like to think about the smaller architectures that exist within the larger ones. So in a house, you also have the plumbing system. You have, in the middle there, I've got an Ethernet set up at my own house and some antiquated security systems. Don't tell anyone about that. Or like the electrical system. So it's, all of these things, to me, also count as like smaller architecture problems that you're dealing with. And so in terms of the architectures that you're working with, there's different levels of architectures, and kind of the gold standard for architecture metaphors is Lego, because everything interconnects with everything else. It's very easy to build a large structure out of Lego. I mean, people build entire like Lego cities. If you go to any of those like Lego lands, you want to change any part of it, it's easy to take parts out and put new parts in. So this is sort of like what you want whatever code you're writing to act like, something that's easy and fun to play with. Sort of in the middle of that is Jenga. So you could build something large out of Jenga, but if you pull the wrong piece out, it's all going to come crashing down. And this is, I think, typically how more applications work, where things have to be in just the right spot or it'll fall down, but in general, you can still keep shifting things around. And then on the lowest level, you have a house of cards where everything has to be in exactly the right place at exactly the right time, or it all comes tumbling down instantly. And if your application's like this, you need to rewrite it quickly. So what we really want is something like Lego. We want to strive for better architectures because it makes it so much easier to write applications. And here's the point where in most architecture talks that I've seen, you get up and you talk about whatever the cool new architecture that you're using at your company is. And so I'm going to say that ModelViewController is the best thing since sliced bread. Which is false. You can tell that that is from Evil Dan, 1, because I've labeled it, 2, because I'm touting the greatness of ModelViewController, and 3, because I drew on a little evil beard. I'm actually incapable of growing a beard, so if you ever see me with an evil beard, you know that you're in the mirror universe and that you should run from me. So I would give up and talk for 40 minutes about some new architecture that I think is the greatest thing, and tell you all how to write this, and maybe your reaction is going to be, I have to switch to this as soon as possible. And this is dangerous. This is very dangerous because what I'm talking about is something very fundamental to how your application's set up. And when you want to adopt a new architecture of that fundamental level, you pretty much need to have fresh code to work with. And if you're starting a new application, great. You've got fresh code. There's no problem there. But if you've been working on an application for 5, 6, 7 years, chances are you've got tons and tons of existing code. And in order to switch to this new architecture, you're going to have to basically rewrite everything. Which leads me to my next problem, which is that rewrites always take much, much, much longer than you think they're going to take. If you've ever heard of Hofstadter's law, it's this law that says everything takes longer than you think it's going to take, even if you take into account this law. So rewrites always take a long time. And also, what you're missing out on is okay, your application's 5 years old. Maybe it doesn't have the most ideal architecture of all time, but at least it's battle tested. Like you've ground out so many bugs throughout the years that like little things that came up, you fixed it in a few minutes, fine, it wasn't a big deal. But now if you rewrite everything, you're throwing all of that away. And then worst of all, maybe you've stopped the world, you've rewritten your whole application, you're using this new architecture, but then it turns out that ModelViewController isn't as great as you thought it was. your expectations for what the architecture is going to bring to your application may not actually match what it does then. So now you've just wasted all this time on a rewrite, and you're unhappy with the results. So instead, my aim here with this talk is to kind of achieve two goals with re-architecting applications. And the first goal is that you should be able to safely introduce new architectures into a existing code base. You shouldn't have things blow up in your face. You shouldn't have to stop the world. And then the second goal here is that you should be able to push releases even while you're re-architecting things. Because you don't want to have to stop releasing. You don't want to say, okay, we're going to take a break for a year, because then your competitors will crush you, like bugs. So it's a lot like remodeling a house. You know, if you're changing a room in the house, this is the White House, in fact, you don't tear down everything every time you want to remodel. You just take part of the house and you change that. Maybe you go live in a different bedroom for a while. That's kind of what the equivalent you want to do with this re-architecting. And I know that architecture talks can be really heavy with housing metaphors, so that I'm going to promise you that from here on out, there are no more housing metaphors. We're just going to talk about code. All right, so goal number one, how to safely introduce new architectures into an existing code base. So what do I mean by re-architecting safely? Two things, and one is try to prevent overly ambitious rewrites, because that's going to make it much harder to release your app, and it's also going to waste a lot of your time if it ends up being that you make some regrettable architecture choices. And it sucks if you wasted a lot of time on something that, if you waste a lot of time, but then it ends up being something you like, that's great. The worst case scenario is you waste a lot of time on something that ends up sucking, and then, oops. So, at Trello, I've sort of developed these steps, these like 4 steps that kind of take us safely for any new project that we take on. And I don't think any of this stuff is groundbreaking, but it's nice just to have this in mind when working on things. The 4 steps I've called explore, experiment, expand, and embrace. And I'm going to go into detail about what these 4 different steps mean, and I'm going to do that through the lens of Kotlin, where we have recently been taking on Kotlin, switching from Java to Kotlin, which you may ask, that doesn't seem like an architecture problem. And my answer is the language, like the coding language you use, is the most fundamental part of any application. So forget you, imaginary person I'm arguing with right now. All right, so explore. So this is the first step. And really what this is all about is figuring out what exactly you're trying to solve. So start with, what is the problem? What exactly are you trying to solve? And this is something that sometimes gets skipped by in architecture. You might just think, hey, I'm going to do something really cool without actually having a well-defined goal in mind. And so what you really want to figure out is, you want to define the goals, and you really want to do this in a way where you figure out, like, what is the absolute best case scenario we could achieve? Because you really want to think about all these lofty things that you could do so that you can come up with the ideal architecture. And then maybe you want to think about what constraints you have. So in our particular case with Kotlin, our goal is that, our problem is essentially that on Android, Java never gets updated. Like, it very slowly does, but for many years, we're stuck on like Java 6 when Java 7, Java 8, Java 9 are coming out. And there are all of these modern language features that we're missing out on that we really want to be able to use, because Java 6 is getting a little long in the tooth. And so that's our goal. Our goal is we want to have a better language. And it looked like Kotlin was going to be a better language. But then our constraint is we've been working on this application for about 5 or 6 years before we started introducing any Kotlin. And we have hundreds of thousands of lines of Java code. And we can't just give that up. So our constraint is whatever we use has to be able to be backwards compatible with our existing architecture. So once you know what your setup is, then figure out what are the solutions that are out there. So oftentimes this comes just from brainstorming with coworkers, what kind of ways you could solve a particular problem, but also a lot of just research on the line, hitting up Google, finding out answers. So once you've figured out, okay, I've defined what the problem is, I've come up with a few possible solutions, then we want to experiment and figure out whether that solution is going to work at all in the first place. And so really this is all about picking a project very intelligently and figuring out whether it's going to work or not. And so you want to pick just the right project for this experiment. And you want to do two things. And the first thing you want to do is you want to minimize the amount of work involved with actually running this experiment. And so you can do that two ways. You can pick a very small project, or you can start using simplified implementations to implement that project. So like, for example, one of my favorite things I've been doing recently is if we want to have a new database table, that's a lot of SQL I have to write. I have to figure out where my indexes are going to be. I feel like I have a lot of pressure to get the schema correct the first time, because in SQLite it's hard to drop columns. So what I've done is I've said, I'm just going to write this like code-based interface, and my initial implementation is just going to be an in-memory database. And that's super simple, because most of the time early on, I'm not even filtering or querying or sorting or anything. I'm just getting all the data from the database table at once. That's just a hash map. It's not a big deal. So that's super fast to write. And yeah, I don't get persistence. I don't get any of the nice performance gains that you get from SQL, but it allows me to like run this experiment super fast, figure out if it's going to work for me or not. And then the second goal of whatever project you pick is you want to minimize the damage caused if the experiment goes awry. So for example, if it's a self-contained project, that's nice, because there's a few experiments we've run. Like I remember one where I read some article about a new philosophy on how object-oriented programming should work, and so I tried this out on one small part of the app that wasn't going to touch really anything else, and it sucked and was awful. But because it was a self-contained project, that experiment could just live on. It was functional code, even if I didn't like how it was architected, and it lived on for like 3 or 4 years before we eventually came back in and rewrote it. And the only reason we had to rewrite was because we needed to add some new functionality to it. And another way to minimize damage is to pick an unimportant project. Because if you pick a really important project, and it's supposed to ship like at the end of February, and you experiment with it, and then suddenly like, oh shit, this architecture sucks, but no matter what, we have to ship it out now because it's due. So pick an unimportant self-contained project, ideally. And so to relate this back to Kotlin, we did the classic thing, which is to first introduce it as unit tests. And so those are, by definition, very small. You can pick as simple of a unit test as you want to start working with at first. It's very self-contained. It actually never ships out with the production code unless you're really messing up something with your build Gradle file. And so it was a very easy way to then like introduce this small piece of Kotlin. The next step is to expand. And so for this, it's really just about running many more experiments. But I'm not talking about just running experiments haphazardly around the code. You want to like pick your projects wisely. And the goal here now is no longer to minimize the damage, but to stretch your architecture to the limits. You want to use your architecture in new ways. Because what you really want to do is find all of the hardest problems and make sure that whatever architecture you're using will actually work for all of those situations. Because the mistake you can make here is that you can say, oh, this experiment went well, it solved my problem, therefore I'm going to go use it everywhere. You add it to all the easy parts of the application, and then suddenly you realize, oh shoot, this corner case that I wasn't thinking about because it's hard and I wanted to put that off to the last minute, turns out I should have worked on that first because whatever architecture I was using is awful for it. And so basically, yeah, stretching the architecture to the limits. So with Kotlin, once we had a unit test and we were liking it, we would bring it into some little bits of the production code to make sure everything's still compiled. But the real turning point was when we were starting a brand new feature, and my coworker said, I'm going to write this whole new feature in Kotlin. And there's therefore no escaping. This new feature wasn't on a particular deadline, so it wasn't too dangerous to do it there. But it meant that there was no escaping Kotlin. You had to use it for every aspect of it. We weren't able to like weasel our way out and say, well, we'll use Java for just this one little portion of it. It's like, no, this whole thing's going to be Kotlin, and then we'll run into all these problems, which we didn't because Kotlin turned out to be very nicely backwards compatible. And then finally, embrace, which is you've run all these experiments, everything's gone well. This is the happy moment where you start writing all your new code in whatever the new architecture is, and that's where we are with Kotlin. All of our new code's written in it, and you tend to deprecate the old architecture. We're trying very hard not to write new Java. If you ever work in an old Java class, we convert it to Kotlin as soon as possible. And then also, you can optionally delete all the old code. But remember that your old code's working, it's battle tested. You don't necessarily want to update. And that is definitely the case with Kotlin. I think I checked like last week, and we're at about 35% Kotlin in our code base, which is nice, but like we're not rushing out to switch the other 65%, because all of that code's working right now. There's no reason to possibly break things. Also, my goal for a while has been to work in the default keynote image into a presentation, and I've managed to figure out a slide where it actually fits. So, woo! All right, so a disclaimer. These steps are a very idealized version of how the whole process works. Things can go very differently. Oftentimes, there is no explore step besides you're given some assignment and you just start hacking away at something. Sometimes 2 or 3 people unknowingly are trying to solve the same architectural problem at the same time. So you are, without knowledge, knowing that you're running multiple experiments, and then one of them just happens to hit upon like, oh, this worked really well for me. This particular solution worked really well, and we should start spreading this around the rest of the code base. So, like, far be it, we're not like writing up like documentation and putting these up into some wiki and saying this is how exactly we're going to run every experiment. Like, you can be much more loose about it. But generally speaking, like when we follow that trajectory, things tend to work out better, either because we safely figure out how to expand our whatever architecture we're using to fit our app, or we catch mistakes early and then start pulling back before that new architecture can wreak havoc on our application. All right, so that's how to kind of introduce new architecture safely. The second goal here was to be able to still push releases while re-architecting your code base, because you just can't take a year off to rewrite everything. I mean, well, maybe your job can. I certainly can't. And so this all hinges on one key observation, which is if what you're doing means that you cannot simultaneously use both the old architecture and the new architecture, that's the situation where you can't keep releasing. Because if the moment you introduce your new architecture, like the old architecture is all broken and stuff, then that's the reason you have to stop the world for so long in order to adapt it. Really, what you want, it's very simple. You want to have the old, and then for some period of time, old and new simultaneously working together, and then eventually just going to the new stuff. So really, this parallel development, being able to have two types of code running at the same time is what makes this work at all. And there are kind of three main strategies that we use to make this happen. And the first is you kind of have to, as a precursor, decouple your code. So if you have code that's like super coupled like this, then it doesn't lend itself well to parallel development. Because if I say want to rewrite how the sockets work, which I've done in the Trello app, and the sockets digs its hands into every piece of every component, like how am I ever going to have multiple things working, like multiple socket paths working at once? Because I have to, like it's just so much work for me to make sure all those connections still function. What you really want is something more like this, where everything is connected at most to like one other major component. And so when things are nicely decoupled, in this case now, look, my sockets only communicate with the network. And so it's much easier for me to take sockets and like replace it with something else. There are entire talks you can give about decoupling code, so I'm not going to get into details of like how this process actually works too much, but like that's kind of like the best case scenario. And then the next thing is feature flags, which is like, I'm so into feature flags. There's one architecture I'm like going to try to push in everyone. It's using feature flags. So a feature flag essentially says when you're going through some code path, you can branch into 2 different directions depending on what you're declaring. So I can have, say I'm going to rewrite the database layer. I can have my UI, and my UI is asking the database for information, and I can say, okay, if the flag is disabled, go to the old database, the old reliable database, which works, but I'm trying to get rid of. If the flag is enabled, go to the new database. And this is really great for a couple of reasons. One is that it allows you to keep shipping code. Like I can say I'm going to work on this new database project is going to take me 6 to 9 months or something like that. But I can say in production, or in dev, the flag will be enabled, so everyone's going to be forced to use it. We're gonna iterate on it and make it better. But in production, I can keep releasing and having the old stuff work. So that's how I can keep releasing while also still working at the same time. Also, depending on feature flags means you can ditch long-running feature branches, which are sort of the bane of everyone's existence. Because what happens is, so-and-so, Joe goes off and works on some feature for 9 months in his branch, which he's not sharing with anyone. No one's looked at this code. And then he comes down and says, okay, I got the feature, and I'm going to merge it all in at once. It's going to be this one nightmarish merge process. If you use feature flags, Joe can instead be just developing this feature piece by piece, merging in these small pull requests, and building up this feature and integrating it. But at no point does it actually have to touch any production stuff. And then the third thing is shims. Shims are super valuable, or just general compatibility between the old and the new. Because at some point, if you're running these two things simultaneously, you're going to not want to be running the old stuff, but you don't want to get rid of it because it's battle-tested code. So for example, there's a bunch of different ways to do this, but maybe I've got my old database and my new database, and I write some sort of wrapper so that even when I'm accessing the old database, it acts like as if I'm accessing a new one. So then I don't have to teach any new devs both ways to access things. I just say, here's the way that we do things now. Or like an alternative way, you can write some sort of converter and then say that, okay, the old database is now going to go through some converter, which then pipes it into the new database, and then the UI really only has one path it needs to go into. I think this is part of the reason Kotlin is so successful as a language, is because it has such a good compatibility story that it allows you to do all of this crosses between Java and Kotlin easily. All right, so that's all kind of abstract. I want to give some concrete examples to that. And so for that, I'm going to talk about one of the longest re-architectures I ever did, which was on the Trello Android app. We made the app work offline. So this was a feature that everyone pretty much wanted. And it's not even explicitly. It's just they expected the app to work this way. You go onto Trello. You want to be able to edit the data without having to have connectivity. It really sucks when you get into a subway or on an airplane, or you're just in a place, or you're like in the middle of rural Iowa, and suddenly you can't use this application anymore. Like all of the functionality shuts down. And so we wanted to make the app work online, but we couldn't really just like stop releasing the app for however many years it was going to take to do this project, because it was a large project. So our overall architecture before why this wasn't really possible is because the UI was going directly to the network to talk about all of these, to basically, it was just going straight to the Trello server and back again. We'd say, create a new card. We'd send out a network request immediately after you press the button. That network request would come back, and then we'd start showing whatever the server told us. And we also had this database layer, which essentially was just one big cache. It would download data, like whenever we made a network request, it would download that data, and then if we open up the UI later, maybe it would be a little bit faster because we wouldn't have to re-download it all. But it really didn't play that big of a role. So to make this work offline, we have to have an architecture that looks a lot more like this. And what the key here is that I can, because the UI never talks directly to the network, I can actually lop the network component off and still have the application work. Because essentially it's all just the UI talking to the database and back again. And then when the UI talks to the database eventually says, hey, we better sync some information back to the network. But that's not an essential part to the application itself working. So in order to do this, first, we had to get the network away from the UI. We had to somehow decouple these things, because they were very tightly coupled together. So what we had is these things called services. So we'd have like a board service, a card service, just a service for any different endpoint that we have in the Trello API. And so suppose I have the UI and I click create card. I'm literally just going straight to this class called CardService and calling CardService.create. So that was the real tight coupling between the UI and the network. So what we really need to do is create an interface. So we essentially extracted CardService was no longer this direct retrofit thing that you call directly. Instead, now there's this interface called CardService, and that's what the UI talks with. And now what we can do is we can fill in one of two concrete implementations here. And one concrete implementation would work offline and one would work online. And the online card service was essentially the exact same card service as before, only it was implementing an interface now. So this was great because then we could develop an offline card service, stick that in. We could use feature flags to stick that in for our local builds. And the UI itself no longer had to know anything about who it was communicating with. Like the UI layer itself didn't have to change at all, as long as we made it so that the offline version of this had the same behavioral behavior in terms of input and output as the online version. But there was another step to the feature flagging, which is that it was a little overly ambitious to say we're going to switch to the offline card service all at once. Because you want to be able to develop these things piecemeal. The card service has like 25 functions or so in it. We only want to be able to convert one at a time. And also there are certain parts of it which we're never going to be able to make work offline just because it requires server interaction in order to work. And so for that, we created something called the CardService Mediator. And the CardService Mediator also implements the card service. And it holds both the offline and the online version. And what this let us do is, for any given function, we would just call like the online version of this function until we were ready to make it offline. And then once we're ready to make it offline, then we can stick in the offline version. But we can also have a feature flag which says, but by the way, only do this for dev builds for some amount of time. So this both allowed us to develop the offline card service piece by piece. We didn't have to do it all at once. And it also let us keep releasing, no matter which pieces we had, production could still work exactly the same way as it did before. Shims came in for different parts of the application. So we have this WebSockets. It's not just us going straight to the network. We use WebSockets as well in Trello so that if someone else on another device changes the board you're currently looking at, we actually get a WebSocket update, which allows us to update whatever the user's currently viewing. And so the pattern that would happen, unfortunately, is that the UI would go change something in the server, it would go say, go create a card, and then the server would respond back, here's your card that we created, and we would just drop that on the floor. The reason being, we're like, we're going to be smart about this. We'll just wait for the WebSocket update, because then the server also tells us, because we're obviously viewing that board right now, that the card was just created. Not great writing, not great code. But it meant that if we wanted to not have to change the UI too much, we'd have to essentially head fake sockets. And so we created the shim here, which I'm calling sockets. And the sockets had no actual connection to the network. It was just this fake layer, this fake shim, which allowed anyone to pump socket updates into it. And so now, we can still get the normal sockets. So the server has some change that comes from another device or our own device. And then that feeds into our WebSocket component. But then the WebSockets talks to sockets, which then talks to the UI. And then alternatively, when we talk to the database, we can say, OK, we're sorry. We know this isn't the greatest architecture ever. But please, when the database updates locally, could you also fire off a fake socket notification? And this allowed us to keep the code pretty much as it stood on the UI layer. So offline mode, how did we do? The project itself took about 1.5 years. In that time, we never stopped releasing. We really had minimal UI changes. I don't know, because if you notice, like basically we never changed the UI component. The UI changes we made were essentially around things that were helping out offline mode. Like we made these sync indicators that show you when things haven't been synced to the server yet. But that was like the biggest UI change. Almost everything else we were able to keep just as it was. We were able to do a lot of gradual experimentation via flags. So we have like a beta program, so we released to our beta users who are our guinea pigs. And for them, we can like remotely change flags and say, hey, why don't you try this thing offline? Why don't you try this thing offline? See where things were blowing up for them, be able to fix it before it was going to make it out to the wider world. And what that meant was that we switched over without anyone noticing, much to my chagrin, because I was like, offline is here, it's amazing, and then no one notices, because they're all just expecting the app to work offline anyways. Like I seriously talked to some people who were like, I'm the biggest Trello fan, I use it all the time, I use the app all the time. I was like, did you notice when offline started working? Like when everything got a lot more stable? And they're like, no, not at all. So Anyways, I actually wrote a series of blog posts about it if you're interested in reading some more of the minutia of what exactly we did to make this work offline. But if it weren't for the fact that we could have both offline and online work at the same time, this project would have never happened, basically, because we could not have stopped the world. We could not have stopped releasing for a year and a half. It would have been insane. All right, now for the fun part of the talk: failures. All the places I screwed up in my lifetime. So I want to talk about where we failed at pretty much every stop of the way, because this is how you learn. So let's go. Exploring, first phase, where you're supposed to do research and development. The first is, I said you have to define what your problem is. Sometimes you just do things without having a problem in the first place. Because we're all engineers, and we like writing stuff, and so we can invent problems where none exist. So architecting with no purpose, obviously, by definition, all of this is wasted time. And so my failure here is this library that we wrote called Navi. And the idea with Navi was that essentially a lot of Android components have this life cycle to them, and it's all the way the framework works. It uses inheritance, and so I was like, it'd be cool if you could plug into any step in the life cycle, if multiple libraries could plug into any step in the life cycle, and not have to force everybody to do this weird inheritance dance. And this actually does have a purpose. Like Google itself released these lifecycle components, which basically do the same thing but much better than what we did. So like it has a purpose to someone. The problem is it didn't have a purpose for us when we did it. So we wrote this. It took like a month and a half or so. It worked really well, and we did nothing with it. And so by just the fact that we did nothing with it meant that it was wasted time, even though it is something that I think is still vaguely valuable, like just going into a project with no purpose. All right, next thing is choosing, when you're researching, choosing something new and shiny without really understanding what you are choosing there. And this is very easy to do because there are definitely fads that happen in the engineering community, and you kind of get caught with the wave and move with it. And so my example here is going to be RxJava, which might surprise someone because I am still a very big RxJava proponent. But the fact of the matter is, when we first started using RxJava in Trello Android, we did not know what we were doing at all. And the reason we adopted it was basically for all the wrong reasons. Now, eventually, once we grew to understand what reactive programming was all about, then we could turn around and be like, hey, actually, this is really cool, and we can use it in this completely different way, which I now promote. But the way we used it originally was all the wrong reasons. Like, we used it basically for threading and futures, which it turns out there is something in Java called threads and futures. Like, you don't need RxJava for that. So I'm still a big fan of it, but the reason we picked it was not great, and we are still suffering now because we have a lot of the code base that's using RxJava in a kind of abusive way. All right, experimentation failures. Making the experiment much too large. So this one, I have to dig back, because basically almost any project that you do without experimenting is, by definition, too large of an experiment, whether you realize it or not. But my example of this is going to be JavaScript of the good parts. So what do I mean by this? Well, I used to be a JavaScript developer way back in the day, and I got this amazing book called JavaScript the Good Parts, which I highly recommend reading if you know JavaScript, if you write any JavaScript whatsoever. It's a great book, and I loaned it to a coworker, and that turned out to be a mistake, because he read the book, and he was like, this is the most amazing thing ever, and I want all of our code base, all of our hundreds of thousands of lines of code to match whatever JavaScript the Good Part says. And one of the things it said in there was that you should be careful of double equals, because in double equals in JavaScript, it can do type coercion. So you can have things where like numbers equals strings because they coerce to the same approximate value. And as you can imagine, that kind of sucks. And so JavaScript the Good Parts recommends using the triple equals most of the time, because then it asks not only are they equal, but also don't coerce any types when you check for equality. So that in itself is a good idea. And my coworker said, great, I'm going to do a find and replace all our double equals in the code base with triple equals. And what he should have done is done it on maybe 1 or 2 files first. And then he would have realized that when you were writing on a 15-year-old code base, people depended on these type coercions sometime. So for the next few months, we had to deal with the fallout here, were just random little bits of code. It wasn't obvious, but little bits of code would break, and it turned out it was because we were depending on type coercion. The other failure you can have here is not recognizing a failed experiment. So you've tried an experiment. The problem is with this, you probably put your heart and soul into it, and you don't want to recognize when things were wrong. So my example of this is something called operations, which is something we added to the Trello Android app maybe 3 years ago. And this was back when we were having a real big functional programming kick, which has never ended. But when we first got into it, again, we didn't fully understand what was going on. And we had this idea of like, okay, you have a list of some model. Let's say you have a list of cards. And you don't want this list to be mutable, globally mutable. That kind of sucks. Instead, what if we create this thing called an operation, where when you want to add a card to this list, I create an operation wrapper object, which I then submit to some operation queue, which then goes and applies the add to some list, which can then be like nicely synchronized in the middle. And if that sounds really complicated, that's because it is, and it was a mistake because like it turns out it's much easier just to go to the list and add an element. Like we weren't writing server software with like 100 concurrent threads trying to edit the same database object. We were just writing UI code, and we could depend on the single-threaded nature to make this easier on ourselves. And so with operations, my coworker wrote one example of it, and in the code reviews, I was like, this seems a little complicated. Are you sure this is right? And he said, yes, I'm 100% sure. And so then he added it to 4 or 5 more places in the app, and then went on to work on something else. And I hate every part of the app that uses these operations, and I want them all to die. Because every time I go into the code base where operations exists, it's like pulling teeth trying to figure out what is going on. Because there's so many layers of abstraction, if I want to figure out like how the hell did this card get added, I have to like go up like through all of these chains of things just to figure out where the source was. It's one of those cases where actually like throwing out the code is generally easier than trying to understand what's going on. And if we had just recognized the first time that like this is not good, then we could have made that a self-contained, horrifying piece of code, but not have to ever touch it again. Instead, it's in a whole bunch of places, and that makes me sad. Expansion failures. This is my biggest personal failure, is choosing only easy problems. So your first experiment worked, and now you try it on more parts of the code base, but what you do is you only pick the easy problems. So this is something for the offline I'm calling identifiers. So with offline, there's this interesting problem, which is though, in Trello, when I create a card, the server sends me back the ID for that card. And now when I say want to change the name of that card, I can say change the name on card ID blah. When you're offline though, you don't have any server IDs. I create a card and I change the name. What do I refer to it as? Like, what do I tell the server to change the card name when I don't even have an ID yet, because I've never done the create sync? So for that, because we were constrained in terms of what the server ID was, we had to make it so that we had both a local ID and a server ID that would exist simultaneously. That idea was correct. It ended up working well. The idea that wasn't correct was, instead of having a single string in all of our models, I thought, hey, why don't we put this object in, which is called identifier, which has both the local and the server ID next to each other, side by side. That works fine. Like, you're just saying that out loud now, it doesn't sound crazy. Why not have every model have both the local and the server ID on it? And so I did that, and I applied it to like all our models, such that they both still had their old server ID, single string server ID, and this identifier. That was me choosing only the easy problem, because then next I was like, okay, so what about the point where something goes from having only a local ID to having both a local and a server ID? And that's where things got really ugly, because I realized all of a sudden that like the ID of each model isn't the only place that thing's referred to. If I have a card, it's part of a list, it's part of a board. That means I have to go cascade so that this identifier object cascade changes through all the different places in the code base that might have possibly been using this identifier. And so that includes not only things in the database, but things that might be incidentally held in memory. If that sync happens right at that moment, I have to go and make sure that every piece in memory is also going to be updated. And when I got to that moment, I realized, oh shoot, this is impossible. Not without like rewriting everything. So I wasted about a month and a half on this stupid project, and I should have tried to, like, instead of implementing an identifier in all the models first, I should have instead looked at, like, one full use case from top to bottom, and then I would have identified part of the problem early on. Another failure is not recognizing a failed corner case. So this is, again, like not recognizing that what you're doing is actually failing. And this is Rx lifecycle in a nutshell, which is Rx lifecycle is something that we wrote fairly early on because Rx Java we were having memory leak problems. And we came up with this nice little solution for solving the memory leak problems. But then after a few months, we realized that there were certain ways you could write the code that would cause this library to mess up. And then when we looked into it, it's like, oh, if it messes up that way, just don't write the code that way and it won't mess up. And that's the moment we should have been like having a blaring alarm going off, being like, don't do this. The fact that you have to write this code in a very particular way without it messing up should be a big warning sign that this is not the way to be going. But unfortunately, we kind of pushed on anyways. So now our code base is littered with this stuff. I actually made a blog post like a few months ago about like, I'm sorry that we introduced this into the world, essentially. There are better versions of this library out now called autodispose, which kind of avoid a lot of the problems. But in general, like it would have been nice if we'd recognized this failure earlier. And then embrace failures. There really isn't too much once you've decided that proved an architecture out. The only problem is continuing to expend way too much effort on an old architecture. And so in the past year, we actually rewrote the way that Trello boards are rendered in the app. And so it's like basically a whole new rendering engine. Very cool. Love to talk about it more, don't have time. But the mistake we made is that we spent too long having both of the code paths exist. And there's all sorts of features that we had to end up adding twice. And so it's good that we could keep releasing production builds, but it was a strain on testers, it was a strain on dev. At some point, we should have recognized if we're embracing this, we should really just go heads down for a month and like finish rolling it out so that we don't have to keep supporting two architectures at once. And then finally, one last pet peeve of mine is discovering a cool new architecture and then telling everyone about it before you've actually proven that it works. My biggest complaint about this was with Facebook. When they first got into the mobile game, they made all their apps WebView-based, and they went out and they gave so many talks being like, WebView-based apps are the future. Because we can write once, and then it produces itself on iOS, and on Android, and on Palm, and on Microsoft, because all those things mattered back then. And what they neglected to mention were two things. One is you need an army of people to fix all of the compatibility issues, and two is that it was slow as hell. And so we'd have managers breathing down our necks being like, why aren't we writing apps like Facebook? They're going out telling everyone that this is the most amazing way to write apps. And we'd keep being like, but we can't, like, we don't have enough people. We have like 2 people here. Facebook has an army of engineers. And then lo and behold, like a year after they went around the talk circuit telling everyone about how great it is, they said we're going to native apps because it'll work better that way. So if you come up with something cool, like use it for a couple years before you start going and telling everyone about it. So with that in mind, some cool things that we're working on these days. I just wanted to mention 1 or 2 things while I have the spotlight. One thing that I've found very cool is this idea of domain-specific models. It's been saving our ass. Right now what we have is something called what I call an omni model. So we have a single class. If you have a card, this card is what is deserialized from JSON using JSON or Moshi or whatever. Then we have ORM light. So it also has all these columns defined in the same class, mind you. And then this same class is also then used by the UI. And this leads to all sorts of nightmare situations, mostly around which fields are present. Because when we make network requests, various fields are present or not present in that resulting response. So that can be one set of fields that are present. In the ORM, a different set of fields are present because we store it in the database slightly differently than it's returned to us from the server. And then you get to the UI portion of things, and things blow up because you weren't expecting this thing to be null that actually turned out to be null. And then the other thing is that we've gotten into the idea of immutable models and having one single class. Like when we deserialize or write it to the database, it needs to be mutable, but we don't want it to be mutable in the UI because that just caused a lot of sadness, especially around caching. So now we have this thing called domain-specific models, which we've been proving out for the last year or so. Instead, we have 3 different models, one for each domain. So you have an API model, And this is only used when talking to the server. And so we can deserialize it. We know exactly what the server is going to return to us, and we can very finely tune it for that situation. And then the moment we get that API model, we convert it into a database model. And this is something that can talk with ORM Lite. It's mutable. It's flexible. Sorry. But it allows us to then kind of decouple what the API is going to return us from what we actually want to store. And then finally, we have these UI models, which is what we derive from the database. But they're nice because they're immutable and they have some guaranteed values. So we can say that like every Trello card must have a name, or it will not, or it simply will not be returned as a UI model. Even if there's this row in the database for it, like we know that we'll crash the app if we try to actually display it. So we've been doing that. We've been doing that for like a year. Things can only be converted. You can't convert an API model directly into UI model because that would cause disasters. So that's one cool thing that we've been working on. The other is unidirectional architectures, which I have so little time now. Oh wait, that clock's a little fast. Anyways, we've been getting into this in terms of the arguments between like MVC and MVP and MVVM and all that stuff, which all seems like a silly argument to me. But we've been getting into this whole unidirectional architecture where you have the model or the database. That then feeds into whatever the user's seeing. Whatever the user's seeing feeds into the user somehow. So this architecture is unique in that it actually accounts for the fact that there is a user involved. That user does something, which is then represented as an intent, which is unfortunate because the person who came up with this idea is a JavaScript developer, not an Android developer, and didn't realize that intent was already taken. And then that intent then feeds itself back into the model as a database change, and it's really simple because I don't have to think about like, well, the user clicked a button, therefore I have to go change the view. No, don't bother. All it has to do is create an intent. That intent changes the database. The view pulls the latest version. I'm not going to get into details here because we're not, like, whatever works for us is, I almost guarantee, not going to work for other people because it's built on this slow experimentation, this slow build-out of various ideas that work with our existing application. And I'm not, like, if I were to start from scratch, I probably wouldn't do it the way we're doing it now. It turns out, but the way we're doing it now is something that actually allows us to build this in the first place. But this is, in general, a very cool idea that I like just telling people about. There are a lot of videos online, if you look up unidirectional architecture, that can go into detail as to how this works. It's very cool if you like actually load up JavaScript or Elm or something like that and try programming this. Anyways, that was pretty much it. Thanks for listening, everyone. If you want to get a hold of me, I'll post the slides sometime later today as well at that Twitter account. Yeah, any questions? A post of examples of what not to do with RxJava. So I think the best thing that I've done about that is there's a podcast called Fragmented, and I went on there. Right near the beginning of the podcast run and talked about RxJava, and then a couple years later went on and talked about like my maturing thoughts about RxJava. That's probably the most, like, that episode was like episode like 98 or something like that. That was probably the one that's best encapsulates like the mistakes we made and how we're using it now. I don't think I haven't written any articles in particular about how we misused it, except for the Rx lifecycle, I'm sorry, oops, article. Any other questions?
So the feature flags that you're using them all remotely, or the development ones?
A mixture. So we have just this one class called features, and in it there's this kind of cool like, and you just create a function that returns a Boolean, and then we have a few predefined stages. So we have like a development stage, and that means it's only shown if you locally built it. We have a testing stage, which means that it'll show up to QA, but also otherwise limit the damage. We have a beta stage that says our beta users will get it, and also anyone who happens to work at Trello will get it as well. And then we have a production stage. And so then that's all hard-coded in, with the idea being that, like, as a developer, why would I ever remotely want to configure this, like even give me the opportunity to make this feature boosted into production when it's being developed right now? And then in conjunction with that, there are also remote flags, which can say, like, as a combination of this feature and this remote flag, determine whether or not that should be shown. And so once we get to the stage where something is actually going to be rolled out to users, then we start setting up the remote flag and saying, okay, this will have an effect. But then the nice thing there is that, you know, the remote flag, we can have a horrible failure of a feature. We can pull it back. Users don't end up keep crashing. But then locally, the feature's flag will still have it show in our dev builds so that we can fix it. Any other questions? Cool, I answered everyone's questions about everything ever. Have a nice day.